The force E needed to make a machine pull a load is partly constant and partly varies as the load L to be pulled. For a load of 20 kg, the force needed is 14 Newton, while a 20 Newton force is needed for a load of 30 kg. Find A, the formula connecting E and L, B, E when L is 50 kg. Okay, let's interpret the question mathematically. We are told that the force E needed to make a machine pull. Please pay attention. Let us represent the force as F. You understand? The force E needed to make a machine pull a load is partly constant. So F is partly constant. So now because it is partly constant, we don't know the constant, right? So let us represent the constant as A. You understand? So F equals to A. Don't forget that A is the constant. Now the F is also the same thing. F is also partly varies as the load L to be pulled. So partly varies as the load L to be pulled. You get what I'm trying to say? F is partly constant. The same F, the force, is also partly varies as the load. Are you getting what I'm trying to say? Okay? For a load of 20 kg, okay? For a load of 20 kg, when the load is 20 kg, okay? Let's do it like this. When L is equals to 20 kg, the force needed is 14 Newton. So the force needed to pull a load of 20 kg is 14 Newton. You understand? And for a load of 20 Newton force is needed for a load of 30 kg. So the force needed to pull a load of 30 kg is 20 Newton. Okay? So we have to calculate the formula connecting E and L. We have to calculate the formula connecting E and L. Effort. We have to calculate the formula connecting E and L. Okay. Now they want us to represent the force as E. You understand? So let us change it. Let's use it as E, and E. From the question, they want us to represent the force as E. Do you understand? So they've given us specification as to what parameters we should represent with E. It is the effort. Are you getting what I'm trying to say? Effort is also the same thing as the force. Okay. So now the formula connecting E and L. To get the formula connecting E and L, we need to know the value of this constant. Are you getting what I'm trying to say? And we also need to change these variation signs to equals to sign. So that's the first thing I'm going to do. Now let us change these variation signs to an equals to sign. Okay. From our basic knowledge of variation in our previous class, if you want to change these variation signs to an equals to sign, we're going to have the effort or the force equals to K multiplied by L. Are you getting it? So effort is also the same thing. The force is equals to A, and the force is also the same thing, is equals to K and L. So if I want to write a single expression for the effort or the force, I'm going to have E is equals to A plus KL. Do you understand? Listen to me. Listen to the explanation again. The force is partly constant. I said let the constant be A, and partly varies as the load to be pulled. You understand? So I said it partly varies as the load to be pulled. So that means that if I want to write a single expression for the force, I'm going to have E is equals to the sum of this and this. Are you getting it? So now, with respect to what we have here, we need to calculate the value of A and K. Are you getting what I'm trying to say? We cannot determine the connection, the formula connecting K and L, and the formula connecting E and L without knowing the value of A and K. So that's what I'm going to do now. To get the values of A and K, we can get, we've been given some important information in this place. They say that L equals to 20 kg and E equals to 14 Newton. So let us substitute those values into this. E is equals to 14 Newton. I'm going to have 14 Newton is equals to A. We don't know the value of A plus KL. L is what? 20. I'm going to have multiply 20L, right? Now, for the second one, we're going to have E is equals to 20 Newton. I'm going to have 20 Newton is equals to A plus, okay? Now, L is now, this will be 20K. Okay? Now, L is now 30. So I'm going to have 30 multiplied by k. See, what I did is that I substitute the value of L and E into this. I got this equation. Then I substitute the value of L and E into this formula. Then I got this equation. So let us combine both equations. I'm going to have 14 is equals to A plus 20k. This k that you see here is this. Are you getting it? So, and for the second one, we are going to have 20 equals to A plus 30k. Okay, now we can solve this equation simultaneously to get the value of A and K. All you have to do is that just subtract equation 2 from equation 1. So I'm going to have this minus this. Are you getting what I'm trying to say? Okay, 14 minus 20. That is what? Minus 6, right? Yes. So I'm going to have minus 6 equals to A minus A. We've already eliminated A like that. A minus A will give us 0. Are you getting it? 20k minus 30k. That's what? Minus 10k. Okay. So to get the value of k, divide both sides by what? Negative 10. So I'm going to have this over negative 10 and this over negative 10. So the value of k is equals to, okay, that will be, reduce this to the lowest term, we're going to have 3 over 5. 3 over 5, okay. So the value of k is equals to 3 over 5. Now, having gotten the value of k, we can proceed to get the value of a by substituting the value of k into any of these equations. So let us make use of equation 1. Equation 1 is 14. Equation 1 is 14. 14 equals to a plus 20k. A plus 20k. Now, when k is 3 over 5, I'm going to have 14 equals to a plus 20 multiplied by 3 over 5. Do you understand? Okay. 14 equals to a plus, now 5 divided by 5 there 4. 4 times 3 is 12. So I'm going to have a plus 12. So a equals to 14 minus 12, which is a equals to what? 2. Okay. So the value of k is 3 over 5, while the value of a is 2. So we can now write the formula connecting E and L like this. E is equals to a, which is 2, plus k. K is 3 over 5. I'm going to have 3 over 5 L. You understand? That is the formula connecting E and L. Now, having gotten the first question, in the second question, we are asked to, In the second question, we are asked to find the value of k, we are asked to find the value of E when L is 50 kilograms. This is the first question. The second question, find the value of E when L is equals to 50 kilograms. Now we are asked to find the value of the force when the load is 50 kilograms. Well, to get the value of the force when the load is 50 kilograms, just substitute the value of L into this formula, then get the value of the E. Are you getting it? So E is equals to 2 plus 3 over 5 L. Instead of L, we are going to replace it as 50. Are you getting it? Multiply by 50, right? Yes. So 5 here 1, 5 here 10, right? 10 times 3 is 30. So I'm going to have E equals to 2 plus 30. So 2 plus 30 is 32. I'm going to have E equals to 32 Newton. So when the effort is 50, when the load is 50 kilograms, the force required to pull the load is 32 Newton. Do you understand? Okay, so that is the solution to that question. Let's look at one more example. The resistance R to the motion of a car is partly constant and partly proportional to the square of the speed. When the speed is 30 km per hour, the resistance is 190 newtons. And when the speed is 50 km per hour, the resistance is 350 newton. Okay? Find for what speed the resistance is 302.5. Okay? That is a WAEC question. So I want you to pay attention. Now, I'm very sure you've written this. Okay? It's simple. You can try it, okay? Try it and give me your answer in the comment section before I solve.
To watch the complete class, kindly click on the link in the description of this video or the comment section, okay? See you in the next class.